We all think the cheapest model wins the contact center AI race.
Actually, bundled GPT-4o token bundles and private link egress flip the math.
So the headline per token rates aren't the whole story.
Exactly. Fine-tuning tiers, throughput discounts, and data egress differentials decide the real TCO.
Welcome to this CRM position deep dive. If you look at how enterprise architecture teams are currently operating right now, there is just this absolute hyperfixation on these headline numbers.
Oh yeah, constantly.
Right. Like everyone is staring at Azure's, 2.15 per million input tokens and $10 per million output tokens for GPT-3o, and they just plug those specific numbers into their spreadsheets, assume those rates dictate the entire financial model for their, say, 5 million token a day workloads, and they just call it a day.
Which is, it's just a fundamental miscalculation when you actually get into the technical documentation, like when you strip away the marketing layer and really look at the billing mechanics, you realize the non-obvious reality is, well, it's far more complex. Because the true total cost of ownership for contact centers, it isn't just about the token price. It's actually dictated by this combination of tiered fine-tuning thresholds, invisible guardrail surcharges, and VNet-peering egress mechanics.
Stuff that's not on the main page.
Exactly. None of which are immediately obvious on a basic pricing page.
And our mission today is to tear that all down for you. We're going to look under the hood at how Azure OpenAI and AWS Bedrock actually price and process CX workloads. We want to, strip away the vendor narratives and show you the architectural reality. So let's start with how this actually works.
Sounds good.
Let's look at that standard 5 million token a day baseline. I want to know how a workload that looks identical on paper ends up completely different depending on a platform's invisible levers.
Yeah, so a really great place to start there is with egress allowances. Azure's bundled GPT-4o offering quietly includes this free 1 million token per month private link egress allowance. And what that practically does is eliminate the data out charges for intra-Azure contact center traffic. So if your environment is operating at that steady state of 5 million tokens a day, that single architectural allowance can shave roughly 12% off your entire TCO.
Wow, 12%.
Yeah, it is a massive structural advantage designed to keep your traffic securely inside their ecosystem.
Wait, but for the non-networking folks listening, what exactly is private link egress? How does that work?
Good question. So private link essentially means your data is traveling over Azure's private backbone network rather than bouncing out to the public internet and back in.
Right.
Azure subsidizes this to incentivize you to keep everything, your telephony, your databases, your AI, all inside their physical walls.
Okay, so Azure is basically giving you a financial break for staying inside their walled garden. But then you look at AWS Bedrock, and they have this completely different mechanism. They have what is essentially guardrails as a service.
Right. And that changes the math entirely. When you apply Bedrock's guardrails to OpenAI-derived models, AWS adds a surcharge of 0.3 Zellers per million tokens.
40 cents, okay.
And here's why that matters. In a regulated contact center environment, applying profanity filters or protected health information like PHI filters, that isn't some optional add-on. You have to do it.
Right, of course.
Imagine a customer reading a medical record or a credit card number to a voice bot. You absolutely cannot allow that data to leak into the training model. So that $1.30 surcharge is practically mandatory for regulated CX use cases. But, and here's the kicker, it remains completely invisible in the headline token rates.
So just to use an analogy here, Azure is kind of like a highway with built-in free tolls for local traffic, but Bedrock charges a hidden premium just to use the seatbelt in a regulated environment.
I actually really like the seatbelt analogy, but that's actually a bit more insidious than that.
Oh, really?
Yeah, because the problem with Bedrock seatbelt is that every time the AI tries to speak, the system has to pause, check the seatbelt, and run those tokens through a secondary, entirely separate model just to ensure it didn't disclose personal data or swear at a customer.
Oh, I see.
That secondary checking process requires heavy computational lifting. That is what you're actually paying that premium for.
That makes a lot of sense. You're paying for the compute to monitor the compute.
Precisely.
And I know the divergences don't stop there. We have to talk about fine-tuning because, well, this is where the cost curves completely invert. Azure tiers its fine-tuning costs based on the model version and token count.
Yeah.
So for GPT-4o, they charge 0.08 per million training tokens.
Whereas Bedrock takes a totally different, much simpler approach. They just apply a flat rate of $0.10 per million tokens, regardless of the model.
So we have 8 cents on Azure versus a flat 10 cents on Bedrock. If I'm just glancing at a spreadsheet, Azure is clearly cheaper.
It is, but only up to a very specific computationally driven breakpoint. That hidden breakpoint is exactly 200 million tokens.
Wait, why 200 million? Like, what is magical about that specific number?
It comes down to how they manage their back-end infrastructure. Azure subsidizes the initial spin-up of the compute clusters to get you in the door, which is why it's so cheap early on.
Right.
But Bedrock distributes the load differently on their back-end, making it a flat rate that actually becomes vastly cheaper at massive scale. So if your fine-tune size stays at or below 200 million tokens, Azure wins.
Okay.
But the moment you cross that line, Bedrock's flat 10-cent rate becomes far more economical. And if your architecture team doesn't know that exact threshold, they just cannot accurately forecast the cost of retraining your routing intents.
I'm looking at these contact center volumes, though, and they aren't flat. I mean, you have massive spikes on Monday mornings or, during a holiday rush. How do these platforms handle that sudden burst of concurrence?
Yeah, that's the real test.
Because when you hit a peak that exceeds 10,000 requests per second, standard pricing basically goes out the window, right?
Completely. And they solve this in two completely different ways. Azure utilizes provisioned throughput units, or PTUs. They offer a significant 20% discount, but the catch is it demands a hard 30-day lock-in commitment for a specific volume.
That's a strict lock-in.
Right. Meanwhile, Bedrock's provisioned throughput gives you a more modest 10% discount, but it imposes a minimum reservation of 5 million tokens at all times.
Which feels like it, punishes variable traffic.
Yeah.
Like if you have pronounced seasonality in your call volume, say you were a retailer in February, that 5 million token minimum reservation on Bedrock is going to massively inflate your baseline cost during your quiet periods.
Precisely. You are paying for capacity you are literally not using. And the structural differences, they extend to the massive data pipelines feeding these models too.
Like the speech-to-text stuff.
Exactly. Consider a heavy 20 petabyte annual speech-to-text pipeline, which is pretty standard for a large enterprise recording calls. AWS charges 0.99 cents per gigabyte for data egressing from its cloud to your on-premise telephony gateways. Azure's VNet-peered traffic, on the other hand, costs only $0.02 per gigabyte.
Wait, let me make sure I heard that right. We were talking about a 7-cent difference, going from 2 cents to 9 cents per gigabyte. What does that actually look like at a 20 petabyte scale?
Well, when you apply that delta to a 20 petabyte pipeline, that seemingly tiny differential translates to an annual hidden cost of about $1.8 million purely in data egress.
Oh, wow. Just an egress.
Yes. It is a massive architectural penalty favoring Azure simply because of how the physical network routing and undersea cables are amortized and priced by the provider.
Okay, let's push this from, spreadsheet theory into production reality. We know the mechanisms now. But where do these specific levers actually break a contact center budget?
Let's look at a real spike.
Yeah, let's look at what happens when Monday morning hits and call volume quadruples. Say a product launch pushes a contact center from an expected 2 million tokens a day to 8 million. What actually happens to the system?
Well, on Azure, hitting that 8 million mark triggers the PTU ceiling you committed to. You bought a certain size pipe, and you basically just tried to push an ocean through it.
Right.
So the system hits the cap, and it causes immediate API throttling. And in a live contact center, throttling doesn't just mean a slow web page.
No, it means dead air.
Exactly. It means dead air on a phone call. It means delayed responses from the voice bot. And honestly, a completely collapsing customer experience.
Okay, so Azure breaks the experience. What about Bedrock?
On Bedrock, the system actually handles the spike. It scales smoothly, and the customer never notices a thing.
Okay, so that's a win.
You'd think. However, because you blew past your provision baseline, you fall back to their on-demand pricing, which is exponentially higher. So the system stays up, but you end up with an invoice at the end of the month that is more than triple your projected cost for that period.
Oh, wow. So Azure breaks the experience and Bedrock breaks the budget.
Basically, yeah.
Okay, but what if I'm a massive global enterprise? I'm not keeping all my traffic in one region. If I split my architecture between the EU and the US for redundancy, doesn't that free Azure highway we talked about suddenly have a toll booth?
That is exactly the cross-region trap. It is incredibly common for global deployments to split traffic. But the moment you route a US-based API call to an EU-based storage bucket, you instantly blow past that free 1 million token intra-Azure egress quota.
You leave the local network.
Right. You are now leaving the local network, and you start incurring that 0.02 cents per gigabyte charge across massive volumes of data. This architectural oversight quietly accumulates a $250,000 annual penalty entirely under the radar.
Man. And concurrently, let's say that same team decides to fine-tune GPT-4o on a 500 million token data set of historical chat logs to improve their routing accuracy.
Well, they have completely missed the 200 million token threshold we discussed.
Right, because they exceeded Azure's cheaper tier without even realizing it.
Exactly. And the compounding cost results in a sudden $40,000 surprise invoice for a single fine-tuning run.
That's the kind of invoice that gets a data science manager called into the CFO's office on a Friday afternoon.
Without a doubt. I mean, it's a resume-generating event if it happens more than once.
Yeah, no kidding.
Yeah.
And then there's the legal and compliance side, which feels like I don't know, a completely different minefield. Compliance is a massive source of structural risk, but the way these platforms package their security tools is fundamentally different, isn't it?
It is a really stark contrast. Azure basically sells you a bundle. They call it the Secure AI Core.
Okay.
This package includes your audit log retention, your model-level access controls, and crucial certifications like SOC 2 and ISO 2701, which prove to auditors that your data centers are secure.
Makes sense.
And it is a flat, predictable $150,000 per year per region.
In AWS, do they bundle it like that?
No, AWS requires a piecemeal approach. You have to separately purchase Amazon Macy, AWS Artifact, and Guard Duty.
Just to clarify for the listener really quick, Macy's doing the data loss detection, right? Like it's scanning the text for credit cards and social security numbers. What are the others doing?
Correct. Macy scans for sensitive data. Artifact is where you actually download your compliance reports for the auditors. And Guard Duty is doing the continuous threat detection, looking for malicious IP addresses trying to ping your API.
Got it.
So to get the equivalent coverage of Azure's bundle for a regulated contact center, piecing those AWS services together costs roughly $300,000 per year.
Double the price.
Double the price, but more importantly, it inflates your operational expenditure by roughly 5% just to manage the fragmented contracts.
And I imagine the real failure mode there isn't just the higher cost. If you have a fragmented compliance stack, you have fragmented human oversight.
Yes, that's the real danger.
Like a single misrenewal of AWS Macy creates an immediate lapse in data loss detection. You are directly exposing the enterprise to a data breach just because someone forgot to click a checkbox in the billing portal.
Exactly. And the risk of active misconfiguration is just as high. Let's say, a well-meaning engineer decides to disable Bedrock's model-agnostic guardrails on a new Anthropic model because they're trying to shave 200 milliseconds off the response time to improve the voice bot's latency.
Right. They want the bot to sound more natural, so they just turn off the seatbelt.
Exactly. But that single policy drift risk means the model is no longer filtering for protected health information. That can lead directly to inadvertent PII disclosure, which immediately opens the organization to massive GDPR fines.
Wow. So if the landmines are this deep, and they are this deeply embedded in the actual code and routing, how do CX leaders actually govern this? I mean, if you're a CX ops lead listening to this right now, you might think the architectural routing isn't your problem.
It is.
Right. If you forecast 5 million tokens and the cloud team routes across region, your budget is the one that gets blown up. We need a practical framework to manage this.
You absolutely do. You need a highly defined REI model, responsible, accountable, consulted, informed, and it has to be driven by the operational realities of these specific pricing levers.
Okay, so what does that look like?
It requires 4 concrete steps. Step 1 is usage forecasting. The CX operations lead is responsible for defining the 5 million token baseline forecasts. They know the call volume, they know the seasonality, but the finance director holds ultimate accountability for the financial impact of that forecast.
Okay, and step 2 is sourcing architecture. This is where you have to choose your poison regarding burst traffic, right?
Yes, cloud architecture leads the critical selection between Azure's PTU lock-ins and Bedrock's provision throughput minimums.
Right.
The CIO is fully accountable for this architectural choice, while finance and procurement must be consulted before any 30-day or annual commitments are actually signed.
Okay, step 3 is the tech strategy specifically, the retrain versus prompt decision. I imagine this falls to the data scientists.
It does, and this hinges entirely on that 200 million token threshold we discussed earlier. The data science manager must evaluate the strict ROI of fine-tuning a model versus just relying on clever prompt engineering.
That makes sense.
They are accountable to the CX ops lead and, again, consulted by finance because crossing that 200 million line dictates whether Azure or Bedrock is computationally viable.
And finally, step 4, continuous TCO and security ops. Because, well, you can't just set this up once and walk away.
Never. Security or compliance engineers are responsible for configuring those guardrails we mentioned, ensuring they are consistent across all models, accountable directly to the CSO with legal and risk management consulted.
Okay.
But crucially, you must deploy a cloud cost operations analyst. Their entire job is to continually monitor the environment to catch things like regional egress leaks before they hit that $250,000 mark. They are accountable to finance, with the executive steering committee kept informed.
So, if we take this governance model and apply it to the long-term roadmap, what does this fundamentally change for an enterprise's AI strategy? Because listening to all of this, it becomes so clear this isn't just about paying bills, this alters how you build the system in the first place.
It does, and it leads to what is probably the most controversial perspective that emerges from this entire architecture. Review Azure's all-in-one GPT-4o bundle actually functions as a highly sophisticated price masking strategy.
A price masking strategy. Explain that.
Think about it. The deceptively low headline token rate of $2.50 in and $10 out lures large contact center operators in.
Right, it looks great on a spreadsheet.
It looks incredibly cost-effective on day one, but the apparent savings evaporate once you factor in the mandatory PTU commitments to handle burst traffic, the hidden egress caps when your global team goes cross-region, and the bundled compliance fees.
So the hook is cheap, but the operational realities eat the margin entirely.
Exactly. For savvy CX leaders who are willing to do the granular, unglamorous math, Bedrock's transparent pay-as-you-go model might actually deliver a truer, lower total cost of ownership at scale, despite having a higher headline price.
And that leads to profound second-order architectural shifts, doesn't it?
Yeah.
I mean, if Bedrock's fine-tuning fees are a flat $0.10 and become incredibly expensive for massive data sets, developers are financially pushed toward prompt engineering instead of model retraining.
Which is a critical constraint. Prompt engineering can only take you so far.
Right.
If you abandon retraining entirely due to cost, you structurally limit your domain-specific accuracy. You lose the ability to handle complex ticket routing intents that require deep historical context of how your specific business operates.
Conversely, Azure's incredibly low $2 costs actively incentivize CX teams to host their heavy speech-to-text services locally within the same Azure region.
And that is a positive architectural shift. By keeping it local and cheap, you reduce network latency. Lower latency directly boosts first call resolution metrics because the AI can interrupt and respond to the customer faster, making the conversation feel natural.
Wow.
But the overarching realization here is quite stark. The cloud provider's pricing sheet is literally dictating your data science roadmap. The financial mechanics are making core engineering decisions for you.
That is a total paradigm shift. You think you are designing the best, most efficient system for your contact center, but you are actually just designing the system that best navigates the vendor's invisible toll booths. It's wild.
It really is.
So let's pivot to concrete execution. We want to give you 3 specific actions you need to take in your architecture this week based on this breakdown. Action 1. Audit your 200 million token threshold.
You must sit down and verify the exact size of your training datasets. Check if your data science team is fine-tuning past the exact volume where your current cloud provider is no longer cost-effective. If they are blindly pushing 500 million tokens through Azure because they think it's cheaper, you are bleeding capital.
Action 2. Trace your egress routing.
Sit with your network engineers and determine the physical path of your data. Are you routing a heavy speech-to-text pipeline out of AWS and eating a $1.8 million annual penalty without realizing it? Or are you splitting workloads between the EU and US on Azure and quietly leaking $250,000 on cross-region network hops? You have to map the literal data flow against the billing tiers.
Action 3. Map your compliance stack.
Ensure your finance team isn't tracking a fragmented $300,000 AWS bill across Macy, Artifact, and GuardDuty when a bundled $150,000 Azure Secure AI Core package would suffice for your regulatory needs. And more importantly, verify that no critical Macy renewals are at risk of lapsing, which would leave your entire operation blind to data loss.
We'll leave you with this final reflection question to consider as you review your deployment with your team this week. Are your architectural AI decisions truly being driven by your engineering needs, or are they being subtly dictated by your cloud provider's hidden pricing levers?
It is the defining question for any total cost of ownership model in this space today.
To truly understand how CRM and AI platforms operate under the hood, you need to look past the marketing narratives. Subscribe to the CRM Position Deep Dives. We break down the complex realities without the hype so you can stay ahead of the architectural shifts that actually matter. Join us and build your stack with precision.